Welcome back. In our previous lesson, we discussed the special properties of carbon atoms. In this lesson, we're going to discuss the ways we represent organic molecules. We're going to discuss the general, molecular, structural, and condensed structural formulae. Right, these are the ways in which we represent organic molecules. Let's discuss them. There are many ways of representing organic molecules. We'll discuss the following. We're going to look at the general formula. We're going to look at the molecular formula, structural formula, semi-structural formula, and the condensed structural formula. Let's start with the general formula. So what is the general formula? The general formula shows the types of atoms and also the ratio of these atoms to one another. Consider the first four alkanes. I know we haven't discussed the alkanes, but let's consider these four. Right, we have methane, ethane, propane, and butane. Let's look at these formulae. Okay, what do you recognize here? Are we able to identify the types of atoms involved? Yes. Alkanes are composed of carbon and hydrogen. If you check here, it's only carbon and hydrogen. And then what about the ratio of these atoms? We can clearly observe that alkanes are composed of hydrogen and carbons. Right, the number of hydrogens is somehow related to the number of carbons. Check this. If you multiply the number of carbons by 2 and then add 2, you get the number of hydrogens. Like here, there's 1 carbon. If you say 1 times 2, you get 2, plus 2, you get 4. And then here, 2 times 2 is 4, plus 2, we get 6. 2 times 3 is 6, plus 2, we get 8. 2 times 4 is 8, plus 2, we get 10. So we can clearly see that if you multiply the number of carbons by 2 and then you add 2, you get the number of hydrogens. So this is showing us the general formula in this case for the alkanes. So the general formula shows us the type of atoms and the ratio of these atoms to one another. It's not about alkanes only. We're going to look at different organic molecules as we proceed. The molecular formula shows how many atoms of each type are in a molecule. How many atoms of each type are in a molecule? Let me give you this molecule. What we have here, we have carbon and hydrogen. How many carbons? We can see that we have 4 carbons and 10 hydrogens. So we have 4 carbons and 10 hydrogens. So the molecular formula shows how many atoms of each type are in a molecule. And then we have the structural formula. The structural formula shows every bond between every atom in an organic molecule. Like these two molecules here, butane and 2-methylpropane. Right? We can see the carbon to carbon bonds. We can see carbon to hydrogen bonds. So the structural formula shows all the bonds between every atom in a molecule. And then we use lines. For a single bond, we use 1 line, double bond, 2 lines, triple bond, 3 lines. We're going to discuss that later. This is for this molecule, which is having 4 carbons and 10 hydrogens. Do you see that we have 2 different molecules here from the same molecular formula? We're going to talk about this when we discuss isomers. We're now discussing the structural formula. What is a structural formula? The structural formula shows every bond between every atom in an organic molecule. And then we have the semi-structural formula. The semi-structural formula shows only carbon to carbon bonds. Like in these two molecules from butane and 2-methylpropane, we can only see the carbon to carbon bonds. We cannot see the carbon-hydrogen bonds here. Okay, so these two are the same structural formulae for butane and 2-methylpropane. So the same structural formula shows only carbon to carbon bonds. The other bonds are not shown. And then we have the last one, which is the condensed structural formula. This formula shows how atoms are bonded in an organic molecule, but does not show the bond lines. We can see how the atoms are bonded, but we cannot see the bond lines, like this one. This is butane we can see that this carbon is bonded to 3 hydrogens and this carbon. And then this carbon is bonded to 2 hydrogens and is also bonded to this carbon and this other carbon. You see that? We can see how these atoms are bonded, but the bond lines are not shown. And then this is 2-methyl propane. That what is the meaning of this? This one in the bracket. Branched or substituent groups are shown in brackets after the carbon atom to which they are bonded. So it means this is a branch, and then it is branched like this, and then it is bonded to this carbon. It's something like this, CH3. Let me draw a semi-structural formula. And then we have the carbon here, and then it's bonded to this branch. You see, this is the branch which is in the bracket here. Okay, and then we have the CH3 like that. Okay, so the branched or substituent groups are shown in brackets just soon after the carbon atom to which they are bonded. So these are the 5 ways in which organic molecules are represented. Make sure you understand these formulae. And then in our next lesson, we're going to look at the functional groups and the homologous series. We'll understand what functional groups are and what homologous series are. Let's meet in the next lesson.